Imagine standing on another planet. Not for a minute, not for 10 seconds, not even for one single second. Because there are worlds in our solar system where the moment you arrive, the absolute instant your body is exposed to the environment, you are already dead. Not dying, not in danger, dead. And the terrifying part is not just how these planets kill, it is how many different ways they have found to do it, how completely and how instantly they eliminate any possibility of survival, and how the science behind each method of death reveals something about the universe that most people have never been told. These are not hypothetical dangers. These are not dramatic exaggerations. These are the measured, calculated, peer-reviewed physical realities of worlds that exist right now in our own solar system, worlds that have been studied by spacecraft, analyzed by some of the most advanced scientific instruments ever built, and confirmed by decades of planetary research to be so hostile to human life that the word dangerous does not begin to cover what they actually are. We are not talking about Mars, where survival is difficult and the challenges are enormous, but the physics at least gives you a few seconds to process what is happening. We are talking about something categorically different, worlds where the laws of physics themselves become the weapon. And understanding why these places kill instantly is not just a matter of scientific curiosity, it is one of the most important things humanity can understand as we push further into a solar system that is overwhelmingly, comprehensively, and in most places, permanently hostile to everything that makes biological life possible. The first world on this list is one that most people think they know: Venus, Earth's twin, our closest planetary neighbor. From a distance, it appears almost identical to Earth in size and mass, and for decades in the early history of space exploration, scientists genuinely hoped it might harbor life beneath its thick cloud cover. Those hopes ended the moment we sent spacecraft there and discovered what was actually waiting beneath those clouds. Venus has a surface temperature of approximately 465 degrees Celsius every single day, every single night, at every latitude, at every point on the surface, without variation. That temperature is not produced by proximity to the Sun. Mercury is closer to the Sun and actually has cooler surface regions. Venus reaches that temperature because of the most extreme greenhouse effect in the solar system. Its atmosphere is 96.5% carbon dioxide, and it is thick, so thick that the atmospheric pressure at the surface of Venus is approximately 92 times the atmospheric pressure at sea level on Earth. That is equivalent to being 900 meters underwater in Earth's oceans. The human body cannot survive that pressure for any measurable length of time. Every organ in your body would be compressed and crushed before your nervous system could even register what was happening. But the pressure would not be the first thing to kill you. At 465 degrees Celsius, every exposed surface of a human body, or any material encasing it, would be superheated beyond the tolerance of any known biological tissue in a fraction of a second. The Soviet Venera spacecraft, built specifically to survive Venus's surface and made of hardened metal with pressure-resistant construction, lasted between 23 minutes and 2 hours on the surface before being destroyed. A human being, biological and fragile, would not survive 1 second of exposure. And there is one more detail about Venus that rarely makes it into casual discussion. Those clouds that look so peaceful from space are not water vapor. They are droplets of concentrated sulfuric acid, dense enough to dissolve most materials, suspended in an atmosphere that also carries sulfur dioxide winds reaching 360 kilometers per hour at cloud level. Venus does not just kill, it kills in multiple simultaneous ways, each one independently sufficient, all of them happening at the same moment. The second world is Mercury, the innermost planet, the closest to the Sun, and a world of such extreme temperature swings that it represents a completely different category of lethality. Mercury has almost no atmosphere. What exists is a thin exosphere so sparse it barely registers compared to even the near vacuum of low Earth orbit. Without an atmosphere, Mercury has no mechanism to distribute or retain heat. The side facing the Sun reaches temperatures of approximately 430 degrees Celsius. The side facing away from the Sun plunges to minus 180 degrees Celsius. And because Mercury rotates so slowly, 1 Mercurian day lasts 59 Earth days, these extremes are sustained for enormous periods of time. A human being on the sunlit surface of Mercury would face the same thermal destruction as on Venus, with radiation exposure added. Mercury receives solar radiation approximately 7 times more intense than Earth does, and without an atmospheric shield, every form of that radiation reaches the surface unfiltered. Ultraviolet, X-ray, and charged particle radiation from the solar wind would begin destroying cellular DNA in milliseconds. The combination of thermal and radiation exposure on Mercury's sunlit surface makes survival not just impossible, but instantaneous in its impossibility. There is no suit, no shielding, no technology currently existing or theoretically near term that could protect a human body from simultaneous exposure to those conditions. The third world takes everything we have described and amplifies it beyond any earthly reference point: Jupiter. We discussed Jupiter's interior in a previous video: the crushing pressures, the metallic hydrogen, the temperatures that rival the surface of the Sun at its core. But what is often not fully communicated is that even entering Jupiter's upper atmosphere, long before reaching any of the exotic interior conditions, is instantly and completely fatal in ways that stack upon each other with almost deliberate thoroughness. The moment a human body entered Jupiter's upper atmosphere, wind speeds of 600 kilometers per hour would begin tearing at whatever structure contained it. Those winds are not surface winds, they are the baseline atmospheric dynamics of a planet with no solid surface, and they do not decrease with depth, they increase. Simultaneously, Jupiter's radiation environment, the most intense of any planet in the solar system, would deliver a radiation dose thousands of times the lethal threshold in the first seconds of exposure. Jupiter's magnetic field traps charged particles in radiation belts so energetic that they degrade hardened spacecraft electronics over repeated exposures. A biological organism would receive its entire lethal radiation dose before the atmospheric pressure had time to become the dominant threat, and then the pressure would take over, increasing rapidly as descent continued, passing the crush depth of any human survivable structure within minutes of atmospheric entry, continuing downward through tens of thousands of kilometers of increasingly hostile gas until hydrogen itself became a metal. No part of that journey offers any pause. No layer of Jupiter's atmosphere is survivable, not the outermost cloud tops, not the middle layers, nowhere. The fourth world on this list is perhaps the most surprising because it is not a planet most people associate with immediate lethality: Uranus. Cold, distant, blue-green, and seemingly quiet compared to the violent drama of Jupiter or the acid clouds of Venus, but Uranus holds a category of danger that is easy to underestimate. Its atmosphere is primarily composed of hydrogen, helium, and approximately 2.3% methane, and it descends through layers of increasing pressure and increasing exotic chemistry towards an interior that planetary scientists believe contains a deep ocean of ionic water, ammonia, and methane under pressures so extreme that the molecules themselves are broken apart and reassembled into forms that do not exist under normal conditions. But the most immediately lethal aspect of Uranus is temperature, combined with pressure, combined with the complete absence of oxygen in an atmosphere that offers no buoyancy, no foothold, and no stable layer where any survival platform could operate. The cloud top temperature of Uranus is approximately -224 degrees Celsius, making it the coldest planetary atmosphere in the solar system, colder even than Neptune, despite being closer to the Sun due to an internal heat anomaly that scientists still do not fully understand. Exposure to -224 degrees Celsius would kill human biological tissue faster than any heating mechanism could compensate for, and the atmospheric pressure would begin increasing immediately upon any atmospheric entry. The combination is different from Jupiter's version of instant death, but equally absolute and equally immediate. Now pull back and consider what all four of these worlds, Venus, Mercury, Jupiter, and Uranus, have in common beyond their individual methods of killing. Each one represents a specific failure mode of planetary formation from the perspective of habitability. Venus formed in the habitable zone but developed a runaway greenhouse effect that transformed it from a potentially Earth-like world into a crushing inferno. Mercury formed too close to its star and too small to retain the atmospheric protection that makes surface survival possible. Jupiter formed at the right distance, but accumulated so much mass that it became a gas giant with no surface and an interior of incomprehensible pressure.
Uranus formed in the outer solar system where temperatures drop so far below biological tolerance that no chemistry we associate with life could function on its surface. Each failure is different, each death is different, but the outcome is identical, a world where 1 second of human exposure is already 1 second too many. And here's what that collection of failures tells us about Earth. Earth did not just form in the right place, it formed at the right time, with the right mass, with the right chemical composition, with the right internal heat to drive plate tectonics and maintain a magnetic field that deflects the solar wind, and at the right distance from a star stable enough not to irradiate its planets into sterility. The probability of all those conditions aligning simultaneously, given what we observe across our own solar system, is something that scientists are still working to quantify, and the more worlds like Venus,